Excellent. All right. So I'd like to welcome to the stage one of our fantastic web developers. Please, everyone give a big round of applause for Alex.
Let's get this set up here a minute. All right. Here we go. Hopefully everyone can hear me okay. So I'm here to talk to you about some stuff to do with AppSec. I'm going to talk a little bit about some old stuff, a little bit about some new stuff, some older stuff that still seems to linger because we just can't seem to get enough people to want to fix it, some new stuff that's emerging with some newer technologies that we're starting to encounter in the kind of space we're working in at the moment. So a little bit about me. As mentioned, I'm a web developer. I've had about 10 years work experience in web development so far. Most of the time, considering AppSec in development, I haven't always worked in cybersecurity, but as a web developer, you want to try and make sure that the things you build are secure. You want to make sure that they work properly, and you kind of try to learn best practices with regards to cybersecurity anyway. So that's kind of a good progression to move into when you're working in web development. I helped build Cyber Discovery, so hopefully you guys have been enjoying that. It seems like it. And generally, my focuses are PHP, JavaScript, and SQL. I know a little bit of some other languages, but that's where I tend to focus a lot of my stuff. And for the majority of my career and my knowledge, it's been self-taught. So why AppSec? Why is it important? Well, apps are everywhere. Web apps, you've got phone apps, you've got apps appearing on smart devices, fridges, toasters, Internet of Things is coming in. People are building stuff and putting it on everything, and they're connected to everything. There's plenty of vulnerabilities all over the place for people to exploit. They're in use longer than anticipated, so stuff that starts out as a prototype that gets put into production that works, the business decision tends to be to leave it working and let's not update it because it's going to cost us money. And unfortunately, code isn't updated, vulnerabilities exist for a long time, and that's a problem. They're playgrounds for the new, the shiny, the trendy. So things that are coming up in new technology, people want to play with them, experiment with them, make things faster, more interesting. But unfortunately, that introduces new vulnerabilities that haven't been discovered, and they end up in production environments and cause some problems. And speed of delivery, it's very often very important to develop things very quickly in the kind of work we do. And so that leads to more vulnerabilities and exploits coming into your code. A lack of experience is another issue we have sometimes when building apps, is that a lot of the languages that are in use are very easy to get things up and running and very easy to put something together, but very difficult to secure properly. And so a lack of experience can lead to a lot of vulnerabilities in this space as well. So slides are boring. We're going to work through some demos instead. The first, I'm going to talk a little bit about cross-site scripting. I would think a lot of you hopefully know about that. There was, I think, some cross-site scripting challenges in-game, but if you're not too sure, feel free to come and talk to me after the presentation. I can walk you through a bit more if you'd like to know. Talking a little bit about cross-site scripting here. And just to set things up a little bit, what we have here is an example of blind cross-site scripting. So typically when you have a XSS vulnerability, you'll see it in something that you can see happening on the screen. So you might have a comment box on a blog post on on Twitter or something. You type something in and you see it reflected back to you on the screen. Here, we're going to do something where it's blind. You don't necessarily know if your attack has worked until you have a response from it. But the way this works is that when you have something that you can have user-controlled input, generally it might be an exploitation point for XSS. So this example here, we have a promotional page that's running, and people might want to track what's going on with this promotional page. They might want to track the requests that are coming in. They might want to keep track of the logs of this page. So for example, if we just refresh this page really quick and hop back here and refresh this, we see there's an extra log that's come in, and in particular it's logging the user agent. Now, the user agent is something that we can control when sending a request to a web server. That's generated by the browser, but we can put in whatever we want to put in. So let's see if we can use that as an attack vector. So if we hop onto here, I'm going to do a couple of things. In this window, I'm just going to set up a small listener that's just going to run in the background and listen for communications coming from my attack. And here, what I've got is just a little bit of script that I put together. Basically, I'm going to send a request to that promotional page, and the user agent is going to be a load of script that I put together. And basically, it creates an element. It sets the element source to a URL that goes to my listener. Then we add the cookie that we're going to steal, in this case, to the end of that URL. We're going to set it to display none so it doesn't show up on the page, so it's nice and stealthy. We're going to append that element to the body of the browser. And just to make it even more hidden, there's an extra user agent appended to the end of the string. So hopefully nothing looks out of place when we fire this off. So if I copy this over here, I need everything. Copy that, we'll come over here, paste it in, send that over. So what we have here is just some output from the curl request saying that it hit that page, return some information. Now if I come back over here, refresh the page again, nothing looks particularly unusual about the log that's come in, but we can see over here on my listener, I've now received a bunch of information. In particular, up over here, we can see we have a PHP SES ID, a PHP session ID, and that's the cookie that we've just stolen from this user. Now what we can do with that is we can use that to authenticate as that person. So let's see if I can select this here. I'll get rid of that bit at the beginning in a second. And we'll go over to an incognito browser over here. And instead, we're going to pump this cookie into here. And if I now refresh this page, we've now authenticated using that cookie. We've imitated this person, and we've now got access to that administrative area. So we can start to browse around, look for more information, find other bits and pieces. And all we did here is we just found an attack point, pumped some script in, and we were able to get access to something. So that's the first demo. I think if we head back to the slides quickly. So here's another interesting example of an XSS that I thought would be quite fun to show. This in particular was a XSS worm that spread around TweetDeck in particular. Somebody noticed that TweetDeck was vulnerable to XSS, in particular using jQuery to make things a bit easier here. So what you can kind of see happening is that they create an element for the script that's going in. This will select that element, go to the parent element and look for the link inside that is to retweet itself. And then it will then retweet itself and share it around. You can see here that this managed to gather about 72,000 retweets, which is not bad for something that managed to spread itself basically like a virus around TweetDeck. Something that is really interesting when it comes to XSS is input sanitization. So the easy solution to preventing XSS would hopefully be just to sanitize your input when it comes in, prevent people from putting stuff into your system that's not supposed to be there. But input sanitization is really hard. For example, this here, it's just a bunch of katakana characters, which is a genuine language that's used in the world. You don't necessarily want to prevent people from putting these characters into your system. But if you run this in a browser, you'll see a hidden message. It will alert something. That there is a piece of script that will run, could be used to inject some malicious code. This here again is something kind of similar. It looks fairly simple. There's nothing in there, there's no text or anything, but if you again put this into your browser, run it in the console or something, you'll see a hidden message and there's a sentence of text hidden in this somewhere. And trying to prevent that from making its way into your system is quite difficult. So next thing I'll talk a little bit about is SQL injection. Again, I think hopefully some of you have encountered this in some of the challenges you've done. If not, you want to talk about it afterwards, come and see me. I love talking about this stuff. So I'm going to do a little bit of a demo on SQL injection here. And there we go, already up and running. Excellent. So here we have just a demo of a branch finder for a bank in this case. The idea here being that you have a bunch of branches down here, and we can search for, if I can type properly, London, and we see London locations. Now, I know that there is a vulnerability in this input box that we want to take advantage of. So the usual way that you would try and do this is you try to confirm that a vulnerability exists. So in this case, if we go back to London, and we can then say, close that out, and then say or 1 equals 1, and then we will add a hash in there. And if we run that, we can now see we see everything. So that query that I've put in has run fine. We know that there's a vulnerability. And we can see what's happening here by looking at the entire query here. So we can say it's saying select something from something where something equals everything we put in there. And you can see it fits nicely between these two existing quote marks. So we've now demonstrated that the vulnerability exists. So now we want to see what we can get from this, this database here. And the common way to do that is using a union query. And that's basically where you take an existing query and you throw another one on the other side. And this, if you've ever used something like a SQL map, that's the kind of way that that tool will allow you to look through the database and pull out that information. Now, one of the things that's important about a union query is that we need to know how many columns exist in the existing query so we can match it on the next query. So we can do that really quick here by saying order by, and let's just put 1. we see the layout of, or the order of this changes a little bit. So we'll just say 2, still changes, 3, still changes, 4, it's changing, 5, stops changing. So we can assume that there is 4 columns on here just from our little bit of experimentation there, and I know that's correct. So if we go back to here, we can have a look at the next query that we want to mess with, and we're going to union a select table name and table schema, and then fill out the additional columns with just 3 and 4 from this information schema database. And that is where MySQL tends to store all its information about the tables that exist in this database. So now, if I pull that query out and we go and run it in here, we can see that we have a bunch of extra information that's come out here that was not there before. The important parts are up here a little bit, so we can start to see some other tables that might be kind of interesting. Up at the top, we've got the branch table, which we can probably assume we were in before we were looking at branches. We can see down here at the very bottom, we've got customer. Now that could be quite interesting. We might want to try and pull some customer information. So let's hop back in here and look at the next query we want to run. It's very similar, except all we're going to do here is we're just going to look for the column name and pad out the other columns from that information schema collection, except we're going to look at the columns where the table name is customer. So let's just grab that, and we'll go back up here and run it in here. And if we scroll down a little bit again, we can see we've got some information about that table. We can see there's email, forename, ID, password, surname, username. Now we can only select 4 columns, so we want to decide which of those are particularly important, but this helps you work out what information you have available. Now, if we go to the next query, here is where we're going to try and pull that information out. We're going to say we want to select the username, the ID, email, and password. That's all information that's probably quite useful to us. So let's hop back in here. And now, if we look here, we can see that we start to have useful information that we've managed to exfiltrate from this database. There's password hashes, which we might be able to crack. There's username information, there's IDs. That's useful information to us. And we've been able to do this without using a tool. And it's fun when using SQL injection to do some damage, to go in there and drop a table, to insert extra information. But this is a nice way that you can get information out without necessarily leaving a trace. And that's obviously something we don't want to happen. So I'll keep it over here for the next demo. I'll slip by the slide a bit later on. We're going to talk a little bit about data leaking and what tends to typically happen here. I'm going to do some demos now using a couple of sites that are built with Node. And the way that Node apps tend to work, JavaScript apps in particular, they usually have a front-end app, which does a lot of the processing of data and displaying that information to the people on the front end. And there's an API that works at the back end that receives requests, will get some information together and send it back over. And because the JavaScript is running in the browser, the API requests that go back and forth are something that you can look at and you can monitor. And we're going to do that here. So over here, I've got a tool called Burp, which is an interception proxy. Some of you might have messed around with these before, but basically it's a proxy that sits between the browser and wherever the requests are going and intercepts it and allow us to look at the traffic, to mess with it, do things like that. So I'm going to turn my interceptor on over here, and I'm going to swap my proxy to Burp. Actually, let's drop that, turn this back on. Going to refresh this, so now we can see over here it's captured a request. Now this one in particular you can see is going to the same domain as the page here, localhost 8081. That just happens to be where I'm running the front end. So we're going to forward that request. The next request that comes through is going to localhost 3000. That's where the API is running in this example. And we don't see anything useful right now, but we might want to ping that API directly just to see if there's anything useful from it. So we're going to send to repeater over here. I'm just going to turn that off. And I'm going to hit that directly. And we can now see over here now that we have a bunch of extra information that might be useful. So I'm just going to throw this in a document over here where we can hopefully see it a little bit better. And if you look at this now, we can start to see that we have usernames, we have tokens, we have email addresses, tons of information that isn't visible on that staff page. All the staff page had previously was just a photo and a name. But by pinging that API directly, we've been able to get access to a bunch of information that isn't really supposed to be shown to regular users. That might have been some miscommunication between the front end and the API team who were building this. It may have been an API which had been repurposed, but this kind of thing can happen. And it's very easy, as you can see, to look at that information directly yourself. So if I now hop back to the slides, if that's okay. And that was the information leak. So next I'm going to talk about NoSQL injection. Now, I won't spend too much on this. I don't know how much time I've got with the issues we had in the beginning, but NoSQL, it's another type of data store. It's similar to SQL, but there are some differences which we kind of outlined here. I'm happy to talk through that a little bit more. Basically, with NoSQL, it uses a slightly different type of data store. Typically, in some of the ones I'm going to do here, it works with JSON. I don't know if there's anybody here who's encountered that. But we can see here, this is the kind of data that you might expect to see in MongoDB, which we're going to be working with today. So here we just have apples, bananas, we have some quantity, and we say that in there we want to do a DB collection find, and we're going to look for anywhere that the quantity is greater than 4. And this kind of greater than here is quite important because that's where we can potentially exploit some stuff. Now, here's just a list of different ways that you can pull data out. You can look for where it's equal, where it's greater than or equal to. These are comparisons that you'll probably see in programming in most places. So I'm going to see if I can do a quick demo of a NoSQL injection over here. And so what we have here is a password reset page. Now, I'm sure many of you have reset a password before. What will typically happen is you'll receive an email which will have something that identifies you, and it will have a token that's been generated for this request specifically, or this reset specifically. And by providing both of those to the server, you identify yourself as the person who submitted the password reset. Now, if we come over here and we break that token, we can see that it says we're not allowed to reset our password. It doesn't like the information we've given it. Now, again, a vulnerability exists in here that we're going to take advantage of. So if I hop back to my interception proxy here and turn that on, similarly, this is an app that displays information on the front end and sends some requests in the back end to handle that reset. So if I hop over here, we'll forward that front end request, and we can see this is the request that's happening to the API. And we have some information here that's being sent over. There's the username and the incorrect token that we were trying to pass over. And what we want to try and do is see if we can inject a piece of NoSQL and see if we can force it to allow us to reset this password. So the common way that you'll see NoSQL interacted with is something like this. So we would inject, say, this string here, and we would say we're looking for something that is greater than nothing, which is kind of the equivalent of 1 = 1 in regular SQL injection. It's saying, show me where the rows are greater than nothing. Pretty much everything is greater than nothing, so this will return the information. In particular, this demo that I'm working with is built using something in Node, which uses a package called QueryString, and it basically it does a bit of parsing for us to try and protect against these attacks. So we're going to use a slightly different method of injecting, which is this down here. This is a different structure, but it means that QueryString is vulnerable to this instead. So for example, if we hop back over here, and we're going to change that token, and we're going to say it's greater than nothing. And if I bring that up so it's kind of fairly prominent, and turn that off, that's forwarded the request with the information I've now put in. And we can see it's now come back and said, I can reset this user's password. This is with the broken token that I had before. So now we've managed to bypass the password reset protection. We can reset this user's password and get access to their account. Obviously not good. I think if we hop back to the presentation, I think there's a few more slides. And I'll pop this over here. So I talked a little bit about Node.js there. Node.js is pretty cool. It's got some nice benefits when you're working with it. It's got some downsides, which we're going to experiment with a little bit here. Now, one of the differences in particular is that traditional web servers have a multi-threaded approach to processing requests. So a request comes in, it's allocated a thread, and that thread will process it until completion, and then it will move on to the next request. If a bunch of requests come in and there's not enough threads to handle it, it will put it in a queue, take it off the queue, and pass it on and continue. Node is slightly different. Node is single-threaded. There is one thread that handles every request that comes through your Node server. And there's a way that it handles this that I'll show you soon that tries to help offset some of that load to web APIs and stuff like that to help keep things running smoothly. But there is a vulnerability there in that if you can find a way of blocking that one thread, you can pretty much shut down the entire server and DOS it by preventing everybody else's threads from, or requests from being run properly. So this is an interesting example if I can pull up my computer. and ignore that below for now. This is a nice demo that somebody else had built that tries to visualize the event loop that's as it's described in JavaScript. In particular, we have what's called a call stack, and basically whenever something tries to happen in JavaScript, whenever it tries to run a function, it sticks it into the call stack. The call stack will take the most important function that needs to be run and pass it off to web apps, and then that will process in the background separate from the node thread. So that's where we can start to delegate responsibility. That will then potentially run callbacks that happen based on something that's happened. It's put into this callback queue at the bottom. When the stack is empty, it will take something from that callback stack and put it into the call stack to be run. It sounds quite complicated, but I think this does a good job of demonstrating that. So if I just press this, we can see things being added to the call stack. We can see things happening as it's running through code. We can see there's a timeout that's happening here. This is running in the browser. That timeout adds something to the callback queue. It's taken from the callback queue into the call stack and then processed. I can demo that again. If I just click this button a few times, it's adding some stuff to the callback queue. That's taken from the callback queue back into the call stack and moved on. So that's how Node is able to process multiple requests at a time, even though it's only running in a single thread. But as I said, single thread means that we can potentially take advantage of that. Now, we're going to look at a regex exploitation here. And regex, as far as I understand, will not delegate those calls to other APIs. So if you can do something with regex to make it take a long time to process, that is our way of potentially blocking the stack here. So we have a page where you can create an account, and we're going to ask for a username and a password. And there's some text here that says your password must not contain your username. That's something that you might see occasionally where you want to try and ask them to have a secure password. We're going to say you can't have your username in your password. And a way that you might try and look for that in code is using a regular expression to say I'm going to look for the value in here and I'm going to search for it in the password. So we can see that in action here. If I just say type in test and just type in something that isn't test, that's accepted. If I went back here and I type in test, it tells us it's not acceptable. Now, here's a regular expression that we put together just to demonstrate this. It's fairly simple. It basically says I'm going to look for A, and then I'm going to look for any number of the combination of B or any number of C, and then I'm going to look for D at the end. And we have two examples here. So first of all, we can demonstrate that the vulnerability exists. I'm going to take this string, and I'm going to add it in here, and I'm going to take the valid one, for example, and copy that. And we're going to put it in the password. And that there, because it matches the regular expression, it thinks that the username is in the password. So that proves that our regular expression string is being passed and interpreted here. Now, obviously, we can change that slightly, and we can change the last character from D to an X and run it. I don't know if anybody noticed with this timer here, the time to run that went up quite significantly just by changing that one character. And the reason that's happening is there's something called catastrophic backtracking in regular expressions. What that basically is if it passes a string and it matches, it's able to say everything's good, I'm going to return it straight away. If it runs through and it doesn't quite match, it will then check another iteration to see if that matches. And if it doesn't quite match, it will check another iteration and keep going until it's checked all of the possibilities and it's certain that there are no matches. The problem with that is you can exponentially increase the number of possibilities that it has to check, and that's what we're going to take advantage of here. So if I start adding in extra characters in the middle here, in particular C, because that's the character it's looking for, you can see that jumped from 0.something milliseconds up to 8 already by adding a few characters here. And if I start adding some more, we can see that it starts to up the time even more. And if I keep going, you'll start to see that there are noticeable delays in the amount of time it takes to process this. And I'm just adding 2 characters at a time here, and now we're starting to introduce visible delay. And this is the thread being blocked on the server. Now the problem is, it's not just blocking this request for you, it's blocking everybody's request that's coming into this server. And obviously, that's not good. You've effectively DOSed this server now. You can set up a script that just sends this, the string with 3,000 characters in it, and that's just going to effectively shut the server down for everybody who wants to use it. Not good. So I think if we hop back to the slides, that's the end of that. So this was just a little bit about that catastrophic backtracking and the strings we're working with and the demo we worked with. And that's it. So does anybody have any questions? If not, it's cool. As I said, if there's anything that you thought was interesting there and you want to talk about it a little bit more afterwards, come and find me. I love talking about web development stuff. I'm happy to go through some things with you. So that's it for me. Thank you.